Welcome, everyone. So great to see you here today with us for our second webinar. The main topic about is MLflow. And today we have our great Yono, who's going to talk about model registry and deployment with MLflow. Don't worry if you didn't catch part one. This is a totally independent webinar, and you can join from this part and be fully ready. So for today, or as I mentioned in the previous webinar, and I'm going to mention it again, contributing to the data science community is one of the core values for us at DAGSUP and something that we're working hard to do. So this webinar is part of this effort to contribute back to the community. And we've integrated MLflow to our systems roughly 2 years ago. And we learned a lot about its internals and how to use it and what's going on under the hood. And this is why we decided to build these 2 sessions about MLflow. So the first one covered MLflow tracking, experiment tracking. And this one with Yono is going to cover model registry and deployment. We are more than happy to have, or excited to have this webinar today. And another side note here is that at the end of this webinar, we're going to draw 5 amazing DAGSUP swag packages for people who are going to follow along Yono and are going to share their DAGSUP repository with their listed model that is going to be registered as a production-ready model. So stay tuned to all the instructions at the end of the webinar. And I feel that with no more further ado, welcome Yono. Now you can unmute.
Yep.
Yeah.
All right. Thank you, Nir. I appreciate the introduction. Hi, everyone. I'm Yono. I'll be your guide on today's journey. Let me go ahead and share my screen. Okay. So here we have at the top a QR code to the notebook. If you haven't gotten a link for that, the QR code will get you to this notebook so you can follow along if you want. Welcome again. I'd like to start off by saying this was a lot of fun to put this course together because I learned a lot myself. I got to dive in really deep, and it's been an amazing experience too. So, as Nir mentioned, MLflow is core to DAGSUP. MLflow has 243 million downloads and 13,000 stars on GitHub. It's one of the most widely adopted open source tools for machine learning lifecycle management. As we've been talking about, it supports live logging of parameters, metrics, and artifacts, in addition to providing the model registry with deployment functionality, which is what we're going to be discussing today. We have integrated MLflow into DAGSUP almost 2 years ago, and it provides zero configuration remote MLflow server with built-in controls. And we support the MLflow's tracking, the model registry, and the deployment functionality. And as I've mentioned already, we've dived into the internals, and we're happy to share with you what we've learned. This is the second part of a 2-part webinar, but you don't need to have seen the first one. You can follow along straight from this one. They're 2 independent parts. You'll just learn even more if you've seen both. If you missed the first part after today's session, you can go out and check out the recording at a link in the Colab notebook, and it's on our YouTube channel. Okay, today we're going to be using DAGSUP's integration with MLflow. You're going to be logging and registering models to a remote server, and you're going to use that server to deploy the same models to AWS. In order to get the most out of this webinar, it'd be helpful to have a DAGSUP account. If you don't already have a DAGSUP account, I encourage you to sign up right now. We're going to give you a couple of minutes to sign up, and then you'll be able to follow along with the notebook and use the remote MLflow server that DAGSUP provides. While we have some people signing up right now, why don't we read a few memes to pass the time? And these are some of the favorite ones that I've found online recently, and they just always make me laugh. This first one, if this is you, don't worry. That's what this session is about. We're going to teach you how to deploy a model. So you won't have to ask anymore. Work fine in dev. Ops problem now. Well, With MLflow, it's not going to be a problem anymore. It's going to be fairly easy to deploy your models and get them working in production. Anyone who comes from my generation, you might be familiar with the movie Zoolander. It wasn't Hansel that Mufasa was talking about. It's so hot right now. It's actually MLOps. That's an inside tip right there. The first version of the script is like that. And my personal favorite, when you combine ML and Ops, you get MLOps. So you have Bruce Banner and the Hulk, and you get Professor Hulk. So what I like about this meme is that the ML makes the Ops a little bit more refined, a little bit more classy. So, all right, I think we've given you enough time to sign up. If you're still working on it, it's okay. We're going to just go on a recap of the previous webinar, and you can just join us when you're done. In the first webinar, you learned about MLflow experiments, runs, logging parameters, metrics, and artifacts. Shimpavi explained how she was able to replace her patchwork spreadsheets and Notion pages she used to track her machine learning experiments with a tool that was actually made for the job, which is, of course, MLflow. In the first webinar, we discussed concepts of experiments and runs and how flexible they can be. And they depend on, and how you use them depends on the situation that you want to use them in. However, if you think of an experiment as a hypothesis that you're testing while you're training your models, and each experiment can have one or more runs. So you could have one experiment in one run, or you could have multiple experiments and multiple runs. You can do whatever fits your style of work, but keeping track of these runs and their parameters and their metrics and their artifacts are how you're going to actually be able to reproduce your experiments later on. And when you're using it this way, MLflow is essentially your digital lab notebook. You're a scientist and you are keeping track of your experiments. Furthermore, we discussed about how there are several scenarios in which you can run MLflow. You can run it locally on your machine, all the way up to having remote servers and using REST APIs between them, which we called scenario 5 at the time. When you use DagSub's integration with MLflow, DagSub does all of this heavy MLOps lifting for you. So you get the best of the scenario 5 situation for you, and you get the MLflow tracking server enabled with proxied artifact storage access. This is a diagram to show you roughly what it looks like. And what's more is because DagSub is providing the remote MLflow server to you, we're actually providing it with every repository, we're actually providing it for free. So there's no extra cost to you, which is how we show that DagSub actually truly loves MLflow. All right, so what are we going to be talking about in this webinar? In this follow-up webinar, we're going to be expanding your MLflow knowledge. You're going to learn about the model registry. We're going to go to the advanced level, basically. The first webinar got you the basics. This one is going to be more advanced. With the model registry, you're going to learn about logging and registering models. You're going to load models from the registry. You're going to deploy models to Amazon SageMaker using the registry. And we're also going to create a Docker image, which can be used on any cloud platform that you wish to use it on, which makes it super powerful. And you might be asking yourself, why is it important to learn deployment? And I was thinking about this question for a little bit, and it came to me in that a machine learning model is only as valuable as its use. If it's hidden away in your basement, it might be the best model in the world, but if no one can use it, it has no value. So a machine learning model is only valuable when they're deployed to production. Its value is derived from its use. And that's, I think, a very important concept. Deployment doesn't necessarily mean to the public where everyone can use it. It could be internally to your company where everyone can use it for internal uses too. That's still deployment. Okay, so the model registry. The model registry that we're talking about with MLflow, this is a centralized store for your models. This is a place to provide a place for you to put your models. It's related to experiments and runs, and it includes model versioning and stage transitions, everything that you need for MLOps. By keeping tracks of these things in the model registry, MLflow makes it easier for you to determine which models you need to deploy to which environment. If you think about it, this is going to make the whole process less error prone. And if MLOps is about one thing, it's about making something repeatable and error prone. Less prone to error. The MLflow model registry has a few important concepts that you need to understand. There is a model, which is created from experiments or runs and logged using MLflow, your framework of choice, .log model. There's a registered model, which is a model that's been registered. It has a unique name. It contains versions. It has associated transitional stages and model lineage and other metadata. A model version is a registered model can have one or more versions. So your initial version when you register a model is going to be version 1, and the version auto-incremented every time you register a model with the same name that has already been registered. The model stage is predefined as actually 4 things: none, staging, production, and archived. Currently, custom stages are not supported, but there is an open feature request to add this, which would be very useful in the future, especially because not everyone follows the same flow as everyone else. And finally, you have annotations and descriptions. So you can use Markdown to add information about your model at the top level or individual versions to help you remember important things about the model that you created at the time. Now, I want to point out the difference between model and a logging model and registering model may sound like they're very similar, but there's a subtle difference between the two, and you can think of them in terms of their purpose. So logging a model is important for reproducibility, and registering a model is important for production. You can, however, both log and register a model in one step, which we will see later on. And just as importantly, the model registry is not just for logging and registering models. You can actually load and deploy from there too. It would be kind of pointless if it was just a one-way path to it, right? You actually need to be able to pull models that you log to it back out in order to be able to use them in production. And this diagram came from Databricks, and it shows how the tracking server and the model registry relate. And here they provide the example where data scientists might be touching there's no experimental stage, it's just none, but they might be, data scientists might be touching the none stage and the staging stage and a little bit of the production stage during handoff. And deployment engineers will be focused mainly on production and archived with a little bit of staging in order to work on the handoff with the data scientists. However, this is just an example, right? If you have a small company, maybe you are both the data scientist and the deployment engineer, and you need to be able to handle all 4 stages. Okay, once you have logged a model, occasionally you'll need to actually update the model. And I don't mean update the parameters of the model. I mean update the metadata or the attributes of the model. For instance, you can change 3 things. You can change the model name, you can change the model stage, and you can change the model tags and attributes. The model name changing is really only going to happen if, for instance, you've made a typo or you've decided that the name you gave to the model is not descriptive enough. It's not going to happen very often, but it's available. Same thing with the model tags and attributes. Usually you'll set them and you don't need to change them again. It's available to change if you need to, but it's not always necessary. The most important one, however, is number 2, changing the model stage. And that's because this is how you're going to indicate that a model has moved from, say, staging to production. And this is going to keep your entire organization on the same page, so everyone knows which model is currently on which servers doing what. Additionally, once
sorry for cutting you off. Your audio is going up and down. So can you just check your input?
Yeah. Is it cutting out, or is it just the volume level?
It's getting muffled.
Muffled. Okay, let me just try a different microphone.
Maybe if you can cancel the noise cancellation or something. Maybe it's the noise cancellation.
Try a different one. Okay. How about now? Is this better?
Awesome. Yeah, much better.
Sorry about that.
Thank you everyone for mentioning it. Yeah, thank you, Balak.
All right. I hope we didn't miss too much, but we're gonna just keep going on from here. Yeah.
We didn't miss anything. It was just like a bit going down, so it was just annoying, but nothing more than that.
All right. Nothing like live demos. We'll see. All right. So let's talk about searching. So I don't know I don't know about you, but I tend to run a lot of experiments, and I like to tweak parameters a lot and see how I like model parameters a lot and see how they react and stuff like that. And once you start creating lots of experiments and logging lots of models, it's going to be difficult to figure out which models you want to use, say in staging and production. Luckily, MLflow has already thought of this and addressed the problem with APIs to do searching. And you can do searching in two different ways. You can either list all of your registered models, or you can search for models by exact or partial names. And it uses a very SQL-like query format. So if you're familiar with SQL, it's very easy to use. We're going to go through some examples, and the examples that we show you are pretty much all you need to know. So it's pretty easy. And model serving and deploying. So MLflow offers options for both serving and deploying, but there's a subtle difference, but it's important. You can think of serving as using the current machine that you're typing on. So when you serve a model, you're going to serve it on the machine that you're currently typing on. Whereas deploying is you're going to create a package, a Docker image actually, that can be deployed and run on any other machine. It could be on the local machine, but mostly you can think of it as a cloud machine that you'll be deploying to. So with that in mind, model serving is a good way to check how your model is working locally before you start deploying. You can serve your registered model using the MLflow command line interface. There's model serve, and by default, it's going to give you a REST API on port 5000. The important thing to note is that the inference endpoint is called wherever your host is, your local host /5000/invocations. Invocations is going to be your inference endpoint. This is not changeable as far as I can tell. Even when you deploy to, say, Amazon SageMaker, it's going to ask you for a name for the endpoint. But what happens is it adds invocations to the end of your endpoint. And that's what you actually need to call when you want to run inference. In case you're interested, under the hood, MLflow is actually using Flask when you're serving models to create the web application. Model deploying, on the other hand, when you're ready to deploy to other machines, you have a couple of built-in options. So MLflow out of the box has support for Amazon SageMaker, which you'll see later today, and Microsoft Azure. However, the community around MLflow is so strong that there are several third-party plugins that have been written by the community members, including to serve on Redis AI, TorchServe, Algorithmia, and RayServe. So this just shows how strong the community around MLflow is, I think. If none of these services are your personal or professional preference, of course, you have a couple of options. Of course you do. You can use the examples from these third-party plugins to write another deployment plugin for your preference. Or, and the nice thing about that is it give back to the community. However, MLflow also has a way to generate Docker images, which wraps your model in a REST API. And this is extremely flexible. This you can send anywhere you want. By creating the Docker image, you have the ultimate flexibility to take your model anywhere. So by default, just so you know, under the hood, Docker image is going to be using Nginx and gUnicorn. And in case you don't know how Docker came about, here we have a meme to explain it. If you're unfamiliar with Docker, don't worry. You don't need to know Docker or have it installed for this webinar. You can do that afterwards. However, if you're not familiar with Docker, you can check out this very beginner-friendly tutorial that I found. All you need to know about it, though, is it's a way to build, test, and reproducibly deploy applications using containers. And you can send this to a variety of supported hardware and software. So it runs on Windows, it runs on Mac, it runs on Linux, it runs on a lot of things, so that we don't have to ship this little boy's machine. Okay, let's talk about what the sample project that we were using as our example. So if you recall, we were working with this small sample model that could classify whether a video game frame contains Mario here on the left or his arch rival Wario. Unfortunately, they don't look like this in our example images. We're actually going to look. They're going to actually be screenshots from grayscale screenshots from Game Boy games. So these are what we're going to be trying to classify here on the left and right. And now it's time for the practical part of the webinar. And I'd like everyone to just quietly say a prayer to the live demo gods, because we know live demos can go horribly wrong. We already had microphone issues. We can see what else can go wrong here, right? And the live demo gods are a mischievous bunch. So if we don't give them their sacrifice, they might screw up this entire thing. However, just know, a week ago, I gave a talk at a conference and I had a live demo. The live demo went very, very, very poorly. But I was able to think on my feet and use the experience to teach a machine learning concept that I wasn't planning on teaching during the talk. So just know if something goes wrong here, I will be good at improvising and we'll have fun and learn something anyway. Okay. We're going to start off by configuring DAGSub. So you want to put in your DAGSub username here and the email which you signed up to DAGSub with here. Next, we're going to select the repo name, which is Mario versus Wario. It should be the same for everyone unless you've changed the repo name for your own purposes. The branch we're going to use is MLflow-102. However, if you want to follow along from your previous webinar, you need to change this to MLflow-101. If you already have a DAGSub repo from the previous webinar, you're going to need to make this MLflow-101. Additionally, this Start Fresh button that's been checked, that's only if you don't already have a DAGSub repo for this Mario versus Wario. If you have it, again, uncheck this box and change MLflow-102 to MLflow-101. I, before the webinar, had deleted my repo, so I'm going to start fresh and pull from here. Next, we're going to get our access token to DAGSub. And instead of, you can either put in your DAGSub password here, or if you want to be even more secure, you can generate a token on DAGSub website and just put the token in here for more security. And now we're going to, if you're starting fresh, you're going to migrate the repository over to your DAGSub account. If you're not starting fresh, this will run nothing. Next, we're going to configure Git with our DAGSub email and DAGSub username. And we're going to clone the repository. So this is going to take care of everything for you. If you're cloning it fresh or whether you're starting from your previous one, this should take care of everything. And next, we're going to install and configure DVC. So I'm going to go ahead and start running this. This could take a little bit of time. If you're not familiar with DVC, DVC is a versioning control for data. It's kind of like the Git for data. And on DAGSub, we use Git to version control code, but we use DVC to allow you to version control data and model artifacts. This will allow you to keep track of everything that you need for your machine learning experiments. You don't need to know about DVC for this workshop, but if you're interested, I've included a link to our documentation for more information about it. Additionally, we're going to go ahead and click this, so MLflow will install as soon as DVC is done installing and pulling. And while we're waiting for this to run, I'm just going to go ahead and pause and see if there are any questions. I can also sing if you like. That's also an option. I'm not very good at it though. Okay. Well, MLflow is installing now. It should be done fairly shortly. Anyone know a good joke? Anybody? No? All right. Okay, so MLflow has been installed. DVC has also been installed. We're going to set up our environment variables. These environment variables are going to tell MLflow where our remote repo on DAGSub is. And we're setting the environment variables so that we can use them either in Python or in Bash. Easy like that. And we'll also import MLflow because we'll be using that quite often. Okay, we're going to do an initial training run before we do anything else. What we're going to do is we're going to rerun the training script that as it was at the end of the first webinar. What this is going to do, let me actually open up the script, which is under Mario versus Wario, source, and train. And if we can just take a quick look at it, you have you have various functions in here. So you're going to get data sets. This is going to get your training and your validation data sets. And this is our get model. We'll put our model together. And with the MLflow we're going to get or create an MLflow experiment and start a run. During this run, what we're going to do is we're going to get that model that we just created. We're going to fit it to our training set, and we're going to pass the validation data set in it to also validate at the end. And we have, we're going to train for 10 epochs, basically. Afterwards, we're going to save the model to the models directory. We're going to log some parameters to MLflow, some important parameters for our model. We're going to log some metrics, and then we're going to log the artifact and just log some text. This should be a review of what happened last time. And the reason we're going to run this training run right now is because I have a fresh ML model registry right now on DAGS Hub. And what I want to do is I want to get an experiment going and a run going and log an artifact. We're not going to register the model yet. We're going to do that after the fact. And so it's important to have something already there. While we run this, it's going to go very quickly even on a CPU, just because it's a very small subset of the data. So it's only like 100 to 200 images. It's going to run for 10 epochs, like I said. Afterwards, it's going to log the metrics to MLflow, to the MLflow tracking server, and then we'll be ready to go. What we're going to do afterwards is we're going to run this script, which grabs the last run ID created on the tracking server. And we're going to put that into an environment variable called run ID, because we're going to be using that run ID very soon in order to register the model that we just trained. So I think we can go ahead and go. And what you'll see is that it returns the run ID is the hash and the environment variable it's saved to. Just to make sure that MLflow sees this, we're going to run this command MLflow runs list and give it the experiment ID of 0, because that was our 0th experiment. And we should see the same run ID coming out in the output. All right, that matches, everything's working perfectly. It's time to talk about logging models. So there are a couple of programmatic ways to log a model. And the first way we're going to do it is called MLflow.register model. And the reason we trained a model previously is because MLflow.register model is the way that you would register a model after you've already completed a run. So you've completed the run, you didn't log and register the model at the time, you want to register it now. This is how you would do it. So we need to import MLflow and OS. We're going to grab the run ID the run ID environment variable that we just set. We need a subpath, and this subpath name for the run, it can be anything you want. Since we're Mario themed, I chose World 1.1 since this is our first model. You need to select a model name. It's very important to select a very descriptive model name, like say Cool Mario Model. And then you need to build this run URI. The run URI has a very specific format, and it's runs : /. It's only one slash, not two like HTTP. That can trip you up if you do that, it won't work. Runs : the run ID / the subpath that you want to create. And then all we have to do is call MLflow.register model with the run URI and the model name, and that will register our model. So if we run this code, we will see it successfully registered model Cool Mario Model, and it created version 1 of model Cool Mario Model. As we mentioned, the first time you register a model, it's going to be version 1. Okay, this is how you register a model after the fact. The ideal way is to log and register a model during training. And that's what the second way to do it is. We have MLflow, the framework of your choice, .log model. This is going to do the logging and the registering simultaneously. As I said, it's best done from the train script. So what we're going to do, so if you look at the call, it's MLflow.keras, because we're using Keras, .log model. We pass it the model, we pass it the directory to the artifacts, and we give it the name that we want to register the model under. In this case, we're going to call it Ultimate Mario Model. What we're going to do is we're going to open up that train.py code again. And if we go down to line 142, where we log the artifact, if we're going to log the model and register at the same time, we don't need to log the artifact anymore. So we can get rid of this line and replace it, copy this line into it. And then we're just going to space it out a little bit nicely. And what this is going to do is after training is done, let me go ahead and save that and close it. After training is done, it's going to log and register our model in one step. So let's go ahead and run. We're going to do another training run. Should go quickly again. After 10 epochs, what we should see is we should see some output along the lines of our model has been registered. Is everyone still following okay? Great. I can only see a few people, but a few people nodded, so I'm happy with that. Okay. Almost done. All right, here we go. We successfully registered model Ultimate Mario Model. We created version 1 of the model, Ultimate Mario Model. Perfect. Okay, now we only have 2 models in our model registry right now, but let's pretend we have hundreds, okay? And we need to find, we want to search for our models. So let's see how we test out MLflow searching. Oh, we have a question from Abid. Should we do it now? Nir, can you unmute Abid?
Yeah, so I think people that are using the last webinar train.py script don't have line 142. So what I suggest is just show the content of that line, and then
sure. I apologize. I probably ran over that a little bit too quickly. Let me bring up the train.py again. Oh, I already deleted it, of course.
I'm going to
Sorry.
unmute a bit.
Yeah. So it was mlflow.log artifacts. It was towards the, it would have been towards the end of the file. I deleted it already, but it was, look for the line mlflow.log artifacts. And in parentheses, it was just the models dir file. So that's what you want to replace. If you don't replace it, it's not a big deal. It's just a good way to do it. Did we have a question from Abid or?
Yeah, I think we didn't have that line. So just at the end of the train.py script, add the code snippet.
And just add this code snippet at the end. Within the with models.startrun code group, add this to the bottom and you're fine. As long as it's after you've created the model and after you've set the models directory, you'll be fine.
Maybe just give us the green light that it's okay. You can send it on the chat.
Yeah. Okay. So we've created 2 models. Let's first fetch all of our registered models. And the way we're going to do this is we're going to create a client that can access the MLflow tracking server by doing mlflow.mlflow-client. Then we're going to use search registered models to loop through all registered models. There is a note here that I want to point out. The parameter filter string should be optional. However, leaving it as none failed to work for me. I don't know if it's a bug in MLflow or if I had some network issues or something like that, but I couldn't leave it to none to fetch all of the registered models. Instead, what I've done here is to mimic that same behavior. I've just added this query string name like %, which if you're familiar with SQL query format, this is going to match all model names. So the % is a wildcard. So this is just going to mimic it. Hopefully we'll figure out what's going on with filter string being set to none, not working. All right, so this is going to fetch all registered models. We're going to loop through the latest versions of each stage of a registered model. This latest versions, if you have models in different stages, it will pull the latest version from each stage. If you only have a single stage like we do, it's just going to get the latest version for each model. So it's only going to be one in our case. And then we're going to print some information about the model. So let's go ahead and run that. And you should see 2 models, and we do. We have our first model, which was Cool Mario model, version 1, no stage, and Ultimate Mario model, version 1, no stage. If you were to match these run IDs with what we showed earlier, you will see that they match too. If you want to query specific registered models, it's very simple, especially since in the previous example, we were already using a query string. So the only difference here is we're going to add cool here before the % sign. And what this does is it'll match any model whose name starts with the word cool. When we run this, we should only get 1 model back, which is Cool Mario model, version 1, stage none. And now remember, the % is a wildcard. So if you were to put % before cool, it would match any model name that ends in cool. If you were to put % before and after cool, it would match any model name that had the word cool in the middle. Very easy. Okay, now let's talk about updating model information. We're going to update the name of the model with code. And then I'm going to show you some other way to update the stage. This is fairly easy to do. We're going to grab our client again the same way. And to register and to change the model name, all we have to do is call the function rename registered model, pass it the name of the model we want to change, and give it the new name. So if we run this, I don't think we'll get any output because it just is a quiet function, but we'll look into that later. The update stage, if you want to do it using the Python API, you would use the client again, and you'd use the function transition model version stage. So our model version is a single version of a model that is registered under a certain name. In this case, we're going to transition the first version of the Great Mario model. And the reason it's Great Mario model is because we just renamed it. And we're going to transition to the stage staging. And again, if you recall, this is what I think you're going to be using most often when you're updating models, is this updating the stage of it. And now while we could run this API here, I haven't made this a runnable cell. And the reason is because we are going to actually show you the web UI and how you can change the stage within the MLflow web UI. So this print statement will print the URL for your repos MLflow web UI. If we click on that and we open it up, we get this web UI, and you can see our two models here. And you can see our ultimate Mario model has already been renamed to Great. So let's go ahead and click on that. And now you'll notice in this version 1, we have our run. You'll see this section right here, stage is none. All we have to do is click on here and choose which stage we want to transition to. Let's say we want to move it to staging. When you move a model to a certain stage, it's going to ask you if you want to transition any existing model in that stage to archive. That's because you generally only want to have one version of a model in a staging thing. So this is a good way to clean everything up at the same time. We don't have anything there, so it doesn't really matter. But if we hit OK, we should see that stage has been set to staging. All right, let me go back to our notebook really quickly. There we go. Sorry, I can't see over the Zoom controls. Okay, now to verify, actually, I did want to show one more thing here, and that is if we go back to models, you should see now that Cool Mario model is still has no stage, and Great Mario model is now on staging. Version 1 is on staging. Okay, now to make sure that everything is still synced, why don't we run our searching function again to make sure that we get Great Mario model on staging. When we run our code, we see that we have Great Mario model, not Ultimate Mario model, and it is on staging, in fact. So everything is synced up between the web UI and our code here on Colab. Okay. What's the point of logging and registering a model if you can't load it, right? So let's talk about loading models. The first thing you need to know is how to construct the model URI, which has two specific formats that you can use. Much like runs, it's models : / and again, only a single slash, 2 slashes could screw it up. Models : / the model name / the version, the model version. So in our case, all of our versions are 1. Alternatively, if you know it's on a certain stage, you can do models : / the model name / the model stage. So let's take a look at an example of loading the model. We're going to put in the Great Mario model as our model name that we want to load. Let's pretend we don't know what version is the most recent version. So let's use our client to get the latest version, and we're going to pass it the name of the latest version of the model we want to get. We know we only have one version of that model, so we're just going to take a shortcut and get the first entry of that array that it returns, and then hit the version and the dot version. We can then construct our model URI by using models : / the name / the version, and we'll use the MLflow Keras specific function load model to load our model URI, because we know it's a Keras model and we need to be able to load it using Keras. When we run this, we're going to get, again, no output. But if everything worked, theoretically, our model is in this model variable right now. Let's figure out how we're going to test that, though. It's important to know that this loading function actually worked. So to test it, what we're going to do is we're going to create a load test image, which is going to take an image path. This is from our test set. So we just grabbed a Mario image from our test set. We're going to use the Keras preprocessing image load image function to load this image into a PIL format. We're going to set the color mode to grayscale because all the images are grayscale. And we're going to set our target size to 128 by 128, which is what our model expects. If you look at the code for training, you can see where that comes from. We then, of course, can't use a PIL image to run inference, so we need to convert it to a NumPy array. And then we're going to normalize the pixel values by divided by 255 because that's what our model expects. We expand the dimensions to include the batch dimensions and return our final input that we can use. So we're going to go call this function to load this one image, and we're going to run inference on this one image. And if everything worked with the loading process before, we should get an output. And what we see is we get an output that the model is of 0.433. So that means it thinks it's Mario, but it's not entirely sure. So it's close to unsure, but it still shows Mario in the end. Okay, so everything's working there. Now you may be asking yourself, what if you don't use Keras? These examples have always been using Keras. Well, there are many other supported frameworks that MLflow supports, including PyTorch and other TensorFlow flavors that you might be familiar with. However, it has an even more generic way to run a model, and that is it has support for generic Python functions. Now, I'm going to pause for a second and repeat this because this is extremely powerful. MLflow can take any Python function you can imagine and turn it into a model and log it and register it. You can do anything you want. You can do custom frameworks that you've written yourself. You can use custom layers in frameworks that other people have created. You can even just create simple math functions if you want and turn them into models. This is extremely, extremely powerful. It's very, very generic. So there are 2.5 things you need to know. So 3 things you could know, 2 things you must know in order to log generic Python functions. You need to create a wrapper class that inherits from MLflow pyfunc.python model. And you need to absolutely write a predict method, which takes the context of how to create the model and the model input. And the predict method should return a value. It's best if it returns a value as a dictionary that can be converted to JSON for when you're ready to deploy your model to the cloud. But it's not a strict requirement. Now, optionally, you can write a load context method. And you may or may not need this, but the load context method is a great place to set up and initiate your model because the load context is only going to get called once, whereas the predict method gets called every single time you run inference. And you don't want to have to recreate your model every single time you run an inference. The context that both of these functions take, we'll talk about later, but we'll see that actually in just a few minutes. So let's take a look at how to create this generic Python function that we can log as a model. All right. What we're going to do is we're going to go through several things of code, and we're going to add it to a file called register_pyfunc.py. This is where we're going to be copying our code, and I've made it super simple. We're always going to copy each block to the end of the file, and we're just going to keep adding to the end. The beginning, what's in there is just stuff to support our stuff. So let's talk about the wrapper class. We have a class called Mario Model Wrapper, and we've inherited from MLflow pyfunc Python model. So we've already done step number 1, check. We're going to go ahead and import TensorFlow, and we're going to import Keras from TensorFlow so the entire class has access to it. We're going to actually use that optional load context method because we want to load our model in this load context method. And the way we do that is we're going to use keras.models.loadModel. But where's the path? The path is actually in the context. So we're going to do context.artifacts and give it path as a key to get the path to the model. I'll talk about more about how you get this context later on, but just know that that's where you're going to get it from. Next, the method you absolutely must include is the predict method, and it's going to take the context and the model input. And because we're going to eventually want to deploy this somewhere, it's much easier to send images as base64 strings. So we're going to assume that our inputs are going to come as base64 strings. Fun fact, actually, the model input is going to come in as a NumPy array regardless of what you want to do, but it's going to be a NumPy array of base64 strings in this case. So we need a way to convert the base64 string into an image so that we can then pre-process it and run inference on it. So these next 3 steps are going to convert the base64 string into bytes, decode the base64 bytes into image bytes, and then create an IO buffer from those image bytes that we can then pass into the next line, the load image. So this is, from this point on, it's the same as we saw in the test function. So we're going to load the image from our buffer using grayscale, setting the size to 128 by 128. We're going to convert to a NumPy array. We're going to normalize the pixels. We're going to expand the dimensions. And then we're going to run inference. But because that's returning a tensor, and we want to have something that we can send back as JSON when we're ready to deploy, we're going to convert it to a NumPy array. We're going to then convert it to a list. And because our model only has one value anyway in a 2-dimensional list, we're going to just grab element 0 and element 0 from that result and package it as a JSON, as an object dictionary. So let's go ahead and copy this into our file. I said just at the end of the file. Perfect. Next, we need to set up the Conda environment so that MLflow knows what libraries are needed to run the model. This is especially important when you're deploying, because it's going to create a Docker image and it's going to install Conda inside the Docker image and set up all the libraries you need for your model. So the first thing that we do is I set up this Python version, and I get the major and the minor version information from the current version that we're running. For the patch version, I just set it at .1. And the reason for this is I ran into troubles where Google Colab was running a newer patched version of Python than was supported on Conda. So Google Colab is running 3.7.14, which came out about 2 weeks ago, and Conda only supported up to 3.7.13. So to work around this, we add the 0.1 here, and then when we set the dependency, we do Python tilde equals, and then give it our Python version. And what this is going to do is it's going to install a Python version up to, but not including the next minor version. So it's going to go up to 3.8, but not including 3.8. So the next version under 3.8. And in this case, it'll be 3.7.13 on Conda. Next, we give it the pip libraries that we want to install. So we want to install MLflow. We want to install Pillow because the Keras preprocessing functions require that. We're going to install Cloud Pickle because that's how MLflow pickles up the model and unpickles it. And in this case, I also specify a specific version. I specify the version that Google Colab is using, which is version 1.5. And the reason I'm doing this is because the current version of Cloud Pickle is 2.2. But if you pickle something with version 1.5 and try to unpickle it with 2.2 later on, it does not work. So we're gonna pin the version of Cloud Pickle to the version that's in Google Colab. And for TensorFlow, I say any version that's greater than or equal to the current version being in Google Colab. We give the name to the Conda environment, which is just Mario environment. It can be whatever you want. It's not even important. You don't see that anyway. Okay. Oh, we have to copy this into our file. I was too excited talking to get on to the next section that I forgot to copy. Let's copy it into our file. Okay. Now let's talk about that context that we were putting into our wrapper class. So you noticed earlier we had context.artifacts and we were giving it a path key. This is how you specify that the artifacts dictionary uses a path key. So we give it path and we give it our models directory. And this we're going to copy into our file. So very simple. You can put other metadata in there if you need for generating your model or for initiating your model. You can put whatever you want, and then you can grab it out with context.artifacts, whatever the dictionary key you need is. Okay, finally, you need to instantiate the Mario model wrapper. We're going to grab our experiment ID. The name of our experiment ID that we used in the previous MLflow workshop was Mario Wario, and so it's the same in all of this code. We're going to start a run with this experiment ID, and then we're going to call mlflow.python.log model. The first part of the model is going to be our subpath, which I've named world1_4. So it's the boss level, in case you recognize that. We're going to give it our model that the model wrapper that we just created, the Conda environment that was up before, and the artifacts dictionary. This is where that artifacts dictionary comes into. And finally, we're going to need a name for our registered model name. So we need a name for our registered model. And because this is the boss level, we're going to choose Wicked Wario model. So let's copy this into our file. And that is everything we need to log and register a generic Python function to MLflow. I'm going to go ahead and close this, and we're going to go ahead and run that code. And if everything works properly, we should see our model logged and registered. I didn't forget to copy anything. There we go. Successfully registered model, Wicked Wario model. We created version 1 of the model, and we're ready to go. Just to verify that we've registered it, let's go ahead and run our code to search for all our models. And we see we have Wicked Wario model at the end with the run ID and version 1. Okay, now comes the fun part. Now we get to deploy to Amazon SageMaker. In order to deploy to Amazon SageMaker, you're going to need to make sure you created and set up an AWS account properly. I'm not going to walk you through this right now. This is out of the scope of this, this course. However, I've put up the steps that you need to follow in order to do that. The first one is a very good blog post about how to create your AWS account. It's got screenshots, very easy to follow. Be warned, you do need a credit card. They're not going to charge you for anything unless you use it. So if you stay on the free tier, you'll be fine. If you start to use something that costs money, then they're going to charge your credit card. But you do need a credit card when you register. You then need to set up an IAM, which is the Identity and Access Management roles, especially for SageMaker. This link is to an AWS information post. It's fine. It's not as easy to follow as the first one, but it's still okay. It'll get you what you need to do. Then you need to install AWS CLI using pip install AWS CLI. And you want to add your credentials to your user directory.aws/credentials. The file is going to look like this. So we're putting in our default space, our access key ID, and our secret key ID. I've starred them out. It's obviously not going to be stars for your case. Once you've done this, MLflow can use your AWS credentials when it's deploying to SageMaker. So you don't have to continually log into AWS, which is very easy and much just, it's a lot simpler to work with. Okay. Now, before we get started, one thing I have to say, we're not going to be running these deployment commands from the Colab notebook. And the reason for this is that Colab does not support Docker. So what I'm going to do is you're going to see me, I'm going to describe the commands, and then you're going to see me go to my local computer, the terminal of my local computer, and I'm going to run the commands so you can see what they look like. So don't expect to be able to run these here. So the first thing we need to do is we need to build and push our container. So this command, the MLflow SageMaker build and push container, only needs to be run once. What this is going to do is going to create a Docker image and push it to Amazon ECR so that MLflow can then use it to deploy models later on. Again, you can run it more than once if you want, but it only needs to be run once. And I'm going to go ahead and do that. No, let's talk about the next command first, and then I'll go back and run both. So to deploy, once you're ready to deploy, after you've built and pushed the container, you need to know your SageMaker execution role, which you created on step 2 of our 4-step process for AWS. And you need to know the AWS region you're going to deploy the endpoint to. If you leave any of these out, you're going to run into problems, and the error messages are not super helpful. You'll see maybe later, hopefully not, but at the end of the course, I've added some troubleshooting links that of things that I ran into, and you might be able, if you ever run into them, they're the solutions on how to get by them. And this was 1 or 2 of them, I have to admit. All right, let's go ahead and move over to my terminal so we can see what this looks like. I'm going to go ahead and run MLflow SageMaker build and push container because I want you to see what it looks like. And as you can see, it starts building a Docker image, and it starts pushing it already. The reason this runs so quickly for me is because I've already done it, so it's very fast. But essentially now I'm ready to go. So now we're ready to try to deploy our model to MLflow SageMaker. So Here what we have, I think I skipped over a couple of the things. So let me try this. Let me run through this again a little bit quickly. So we have MLflow SageMaker deploy. The app name we're giving it is whatever we want. In this case, I'm calling it Mario. Our model URI is the same way that we've talked about model URIs in the past. So we're going to choose Wicked Wario model number 1. We then put in our SageMaker role in our region. When we hit return, you're going to see it's going to start the deployment process. This process takes a little bit of time. Let's go ahead and start it because I want to show you what it looks like in SageMaker. So now here it says right here, waiting for endpoint to reach in-service state. The current endpoint status is creating. This is going to keep printing this out over and over again until it's gotten confirmation from AWS that the endpoint has been created. And this is going to time out after about 20 minutes if it never gets properly created. So if we move back over to here and we look at Amazon SageMaker, if we scroll back down to inference and look at endpoints, we're going to see Mario. This is the one we're currently creating. And Mario 2 is one that I created before, which is already in service. So you can see that it works. All right, while that's running, let's go back to the Colab notebook because this is the part that I am super excited about too. So SageMaker is great, but what's better than being able to deploy to one cloud endpoint? It's being able to deploy to any cloud platform, right? So let's talk about creating Docker images. It's very simple to do. You just run MLflow models build Docker. You give it the name of the Docker image you want it to be called. In this case, Mario. It could be whatever you want. And the model URI the same way we've always been doing it. So model / the model name / the model version. Once you've built the Docker image, you can spin up the Docker container using this command, docker run -d -p 8080 8080. So 8080 is the port that it runs on. So essentially you're saying the external port is 8080, the internal port of the container is 8080, and we're going to run Mario latest. I forgot to mention, I mentioned this earlier in the webinar, but I didn't repeat it. I should have repeated it. Don't worry about trying to install Docker and running it now, especially if you're not familiar with Docker. This is something that you can do later. This is something that you can go through the Docker tutorial that I linked to earlier and get to learn it a little bit better. But just know that Docker is super cool, very powerful. And if you have a chance, you should definitely learn it. Okay, so let's go ahead and build our Docker container. We're going to go back to our terminal here. And I'm going to run the command MLflow models build Docker name Mario, and the model URI is going to be the same one, the Wicked Mario model number 1. When we hit return, it's going to start building our Docker container. This is going to take a little bit of time because it takes some time to build Docker containers when they're not pre-built. While it's building, after it's done building, we're going to run our Docker. We're going to run our Docker container. I said Docker container earlier. I meant Docker image. So we're building the Docker image. We're going to run the Docker container. So a container is kind of like an instance of an image. Once we've run our Docker container, once we've built our Docker image and run our Docker container, we need to know how to run inference on it. So let's go over how to run inference to our Docker container. So we're going to be using the curl command to ping our Docker container. And I mentioned before that we need to be able to send a JSON dictionary, a JSON to our curl command or to our Docker container in order to read it. And we're going to be sending a base64 string representation of the image. So our input, the input that we're going to be sending via curl is just going to be a dictionary with the key of inputs, and the value is going to be the base64 string representation of the image. And the example of how we're going to do this is we're going to do curl to our local host / invocations. Remember invocations from before? That's the endpoint that we always have to call to run inference. We need to set the content type to be application JSON. And then we set the data that we're sending as inputs, and this command in bash to convert mario0.jpg into base64 string. The -w0 just make sure that it doesn't cut up the base64 string into separate lines. It needs to be all in one line for it to work. Let's go check on our progress. We should be almost done. So close. Well, the good thing is I've already run this in the past, so we can go ahead and run our we can run our Docker container from the previous version that I've run. So this command, you'll start to see a bunch of things being run. You'll see warnings and information and sometimes errors, but nothing catastrophic. Everything is running. The Docker container is fully functional now. And now we should, perfect. Deployments, oh, here we go back to our AWS, our deployment operations completed successfully. So let's go ahead and, however, let's go ahead and ping our Docker container with our image. When we run this command, we should get back our result. And you can see our result is 0.72 in this case. This was an older model since I didn't let the other Docker image finish building. But for the model that this was based off of, it thought Mario0.jpg was actually Wario. So very simple. As we can take a quick look at AWS and you should see that both Mario and Mario 2 are in service now. All right, perfect. This brings us to the end of our webinar. And I appreciate all of you that have stuck with the whole thing and stayed till the end. I mentioned earlier that at the end of the notebook, there are typical errors. And by typical, I mean errors that I ran into and had to figure out how to solve. So I thought it might be helpful for you in case you run into them. And I'm not going to go through them right now, but if you run into any errors, check here first to see if you can figure out any issues that you might run into. All right. Do we have any questions? I will sing if no one asks a question. It's the threat.
Yeah, I know Yono for a while, and we don't want to let Yono sing. So please, questions, people, questions. No, I'm kidding. Cool. So thank you so much, Yono. I feel like this was a great session. Not being biased. And if you have a question, I already see that we have one, so I'm gonna enable you to unmute. If you have any questions, feel free to either write them on the chat or raise your hand here, and I will enable you, allow you to unmute yourself and ask the question. It can be about MLflow, about DAGZUB, about setting up MLflow, about the MLflow experiment tracking that we covered in the previous part, really about anything. So without any further ado,
Hi, Yono. So I have one question regarding this entire process. So I know like right now we are running this all all the functions of MLflow on Jupyter Notebook. But I'm just asking, like, if you use this in industry, how do you do so? Like, do you just automate all these scripts in Airflow, or do you just run all these scripts through containers? Like, what is the, I would say, default process to run all these scripts like automatically instead of just, running like these Jupyter notebooks?
Right. That's a fantastic question. So the nice part here is because of the flexibility of the Python API, it's not very particular. You can, if you do your training runs through Jupyter Notebooks mainly, you can do that without any problems. I like to have my code in scripts that I can just run, especially for long running training runs. I like to have my code in scripts that I can run in the background. Sometimes I will actually even spin up Docker containers to do training runs for particular experiments. And for me, it's just more of what I'm currently working on at the time. I don't have a good reason as to why I would use a Docker container to run my experiments versus staying in a Conda environment. Some of my machines are set up more to use Docker, and some of them are set up to more to use Conda. But either way is fine. It makes actually very little difference. MLflow is agnostic to that, so it's quite powerful in that respect. Additionally, the nice thing about if you do the training runs, say, separately in a file, the nice thing about the Jupyter Notebook is that you can get the immediate feedback if you want to run, say, like the searches and stuff like that, and tweak parameters and tweak attributes and whatnot. So I like to use the notebooks for immediate feedback, but I will use the training scripts to just run long-running training sessions. that makes sense.
Okay. Okay. Because you know why I asked this question, like at the end, you need to automate the entire process, kind of like making a CI/CD pipeline. And we need not to like, every time running a single piece of code in a Jupyter notebook, we want like everything is running and we are finally looking at the metrics. You know what I mean?
Okay. Yeah. I mean, in that case, if you're automating, I tend to not use notebooks for in my automation processes. I will then at that point create Docker images that are specifically set to essentially run an application and stop when they're done. So that's the nice thing about Docker is that you can have it set to run a single application. So like a single training run, you can pass it even parameters, and then when it's done, it'll just spit out the output wherever you need it to, or log it to MLflow, for instance, and then stop running. So that's the nice. It makes it a lot easier to automate, especially if you also don't know what machines you're going to potentially be training on. So you can train on a variety of machines that way too.
Sound good. Thank you so much.
Yep. Well, let me stop sharing so I can see people.
So we have a question from Surab about how to contribute to DAGZUB. So first of all, thank you for your kind words. And if you are looking to contribute to DAGZUB, then we are currently participating in the Oktoberfest, and we have 3 active challenges where you can either contribute 3D model data sets or audio data sets, or to connect GitHub repositories that host reproduced papers from Papers with Code and add to those papers the data set and models using DAGZUB storage, and this way make them fully reproducible and accessible for the community. However, if you have other topics that you want or projects that you'd like to contribute to, then you can easily go to our Explore page, filter by the topic or domain that you'd like to focus on. So if it's computer vision, NLP, etc., and find either opened issues and close them. So contributing by pull request, or you can open a pull request with a new model, a new experiment, a new data set, a new code. So basically all project components are supported by DAGZUB. And this way you can also contribute to work on a domain that you are more professional. Regarding the webinar, if you're going to have another live webinar for the MLflow experiment tracking or the deployment and registry, then we are planning to do so, but we're not sure in which quarter we're going to have it. So it's either going to be in the first quarter of 2023 or the following one. But if the crowd or the community is going to ask for another one, then we're definitely going to prioritize it. We are we're trying our best to listen to what the community is asking and do our best to answer to it and provide their needs. So if the community is going to ask for it, then we're going to prioritize it. On that note, if you have other open source tools that you'd like us to cover next, to have the next webinar on, then feel free to suggest it on our community Discord or project, the ICDVC. You are reading our minds, yeah, so probably DVC is going to be the next one. But if you have other tools that you feel like it's going to be more valuable, like Label Studio, Jenkins, etc., just post it on the suggest a project or suggestion channel that we have on our community Discord, and we'd love to, and we'll do our best to prioritize it. Any more questions before we wrap it up? Awesome. So thank you everyone for joining us today. It was amazing. I feel like, Yoni, you managed to take a bit of a complex topic and make it very easy to learn and to use, and also to follow up during the webinar. So great job. And thank you for doing that. I want to thank you all for joining us today. As I mentioned at the beginning of the session, we're going to draw 5 full DAGZUB swag packs that we're gonna ship directly to your home. So no matter where you are on the globe, those swag packages are gonna reach to your doorstep. So if you want to participate, you have 1 week to participate in that draw. So just post your DagZab repo with your register model to our LinkedIn post. We're gonna share it also in the post-webinar email with all the details. So that's it. If you have any more questions, feel free to reach out on our community Discord. And without any further ado, thank you so much for joining us, and see you on the next webinar.